And welcome to the second session of security architecture and engineering, which is the domain 3 of CISSP. What we have seen in the last session is the definition of security architecture and engineering. Dominantly, architecture pertains to design, and engineering is what is related to the actual implementation. Now, both the design and the implementation should be based on certain design principles, and those are actually what is called as secure design principles. And there are many, so we will look into each one of them one by one, and then you will understand how, in totality, all this together works to make a system secure. First and foremost is what you call as a least privilege principle. What that is something that you have also seen in the first domain, risk management, uh, and that pertains to what you call as what is the minimum that a system or a person or a process require to finish the job. In terms of cloud architecture, least privilege is sometimes also called as just in time. That is, when a process on a cloud requires an access, it gets that access to perform the job only just in time, and once the task is completed, the access is taken away. It is further extended by what you call as need to know, which means do not give access, either read, write, and definitely not edit to something or someone who doesn't need to have that access. And this is one of the most technically challenging principles to actually implement, because invariably the overarching design sometimes gives extended rights to people when or to the processes when they shouldn't have that. Now, to curtail this, there is the next design principle that is called separation of duties, wherein we define the exact roles the employees or people should have, how technically two processes should have access on a certain file, and then define how each one of them access based on what is a specific role or the access on a task that has been defined to the process. So that is like separation of duties, so as to make sure that there is a clear demarcation of who is doing what, but also that one person or one process does not an overarching powerful reach uh, to the asset that it may create an absolute harm, or it have the possibility of creating an absolute harm to the asset if it is misused. Now, to extend this concept, there is also something called as defense in depth, which is called layered defense or an onion defense, just like the layers of onion that you see, that one covers the other. And this defense in depth strategy is about how it is to make for an attacker the chance of getting to the system more and more difficult. It may so happen that even with the best of capabilities and best of security defenses, the organization may still get breached, because breach may also can come from inside. So therefore, your defense in depth strategy should be such that it is able to delay the attack or to make it harder as much as possible for the attacker to perform the attack, and also to also manage to get to the valuable assets or to the systems in terms of misusing it. So defense in depth is a very important concept in that. One aspect of defense in depth is that your layers should be compensating or mitigating the weakness of the layer either in front of it or either behind it. If all the layers have the same weaknesses, then the defense in depth is as good as having one layer with the same weakness. It is also important to know that fixing any of the security problems early in the design of the system is much more cheaper, much more manageable than rather doing it at the end of it when the system is either deployed to production or it is on the way to production. So this is fix first, fix early. That is where the momentum is. Now, other aspects of secure design principle include secure defaults, how you harden your system. For example, when your system shuts down, does it shut down keeping the doors open, or does it shut down completely keeping everything closed? Now, the purpose of secure defaults or system hardening is to make sure that the attack surface that is being uh, accessible to an attacker is minimized. So, for example, the number of doors in your house, the number of windows, the number of ports in the operating system is closed or is monitored to make sure that the attack pattern, that the attack surface is minimal for attacker to come in. There are also other aspects of a design principle which is like fail securely, which is dominantly have to do with exception handling. So for example, when your system fails, what kind of exception that is thrown, because you also want to know why the system is failing. If your system abruptly shuts down, then it becomes difficult for you to know why it happened, and it's even more difficult to guess if it will happen again or not, and when will it happen again. So that's why the exception handling aspect is also very important. One of the key design principle as it is propagated in system design is to keep it simple. However, it is also a material fact that once you start building a system, the complexity creeps in by virtue of using multiple vendors, different technological stack, sometimes incompatible technological stack, which then aids to, to the increase in the complexity. There are also principle related to how you configure your system. So for example, trust with verify. For instance, you have let the port open for particular process to access application gateways. However, make sure that every time they come into access application, you still verify. Is it like your neighbor rings your doorbell, but you still see through the camera or through the uh, door, through the peeping hole in the door, to make sure that you recognize the person who is ringing the doorbell. So this is trust, but still you are verifying. There is also a concept of zero trust, which means do not trust ever, verify always. Now, this is uh, a critical this aspect has a very critical implementation downside, because if every time you have to verify every connection that is coming to your application, you can imagine in a retail application where millions and millions of users may logging in, this may create a bottleneck, and this may also create a downside to your application performance. So these principles are also need to be implemented considering given the context in which you want to implement it. Just like security by design concept, there is also privacy by design to protect your privacy. And the important aspect of privacy and security is that they both has to be winner. One should not lose for another. That's why it's a zero-sum game. And as you have seen in the case of cloud security uh, concepts in under CISSP domain 1, risk management, you know that the shared responsibility is a governance model that is defined between customer and the cloud provider, but it has to be implemented both sides. Otherwise, a weakness in one will expose both the vendor and also the customer. So that's about it. I'll stop here. I hope to see you in the next session. Thank you very much.